Okay, today we're going to be looking at logarithmic equations. So to solve exponential equations, we use a log to undo it. To solve a log equation, we're going to use an exponential to undo it. And so we're going to use the definition of a logarithm, meaning how do we rewrite it in its exponential form to solve these. So first, you need to get the log expression by itself. Once you have that by itself, you're going to switch it to its exponential form, and then you are able to solve. Now, remember that we have talked about the domain of log functions. Log functions only work for positive numbers. So you do have to check your solutions for extraneous solutions. If you plug anything in and it gives you either log of 0 or log of a negative, we have to throw that solution out. Okay, so for example, number 12, the log is already by itself. Log base 2 of x minus 4 is equal to 3. We've seen there's no way to split that log apart. So we're going to rewrite this in its exponential form. So we're going to use a base of 2 and an exponent of 3, and that should equal what's inside the log. Look at what we've accomplished now. The x is not trapped in the logarithm, and 2 to the third, we know we get 8, x minus 4, and so we add 4 to both sides, and we get that x is equal to 12. Now we want to do a quick check inside our log. 12 minus 4 gives us a positive number, so 12 is a good solution, and we are going to keep it. Okay. Now on number 13, we would have to first divide by 3 to get the natural log by itself. Then we're going to rewrite it. Okay. So I would like for you to pause the video and go ahead and try 13 and 14 on your own. Come back here for the work in 3 seconds. All right, so for number 13, notice I left it in its exact form, which is e to the 4th over 2, which then if they ask you to, you can round to a decimal by using your calculator. So that's what you should get for number 13. For number 14, it's very similar to number 12. We get x equals negative 12 for an answer. Now, negatives on their own are not bad. We have to check the solution in here. If I plug in negative 12, I get the log base 2 of positive 8, which is fine. If I had gotten something like negative 22, that we would have to throw out because that would give us log base 2 of a negative number, and that does not work. Okay, now, those are pretty simple. If you have more than one logarithm, we cannot use that strategy until we get it condensed to a single logarithm. So this is where our properties come back in. So for number 15, we have the log base 2 of x plus the log base 2 of x minus 7 equals 3. First, we have to condense this, and addition condenses to become one log with multiplication inside. So we get, the log base 2 of x times x minus 7 equal to 3. And so when we rewrite this in its exponential form, now we have 2 to the third is equal to x times x minus 7. This is going to come out to a quadratic when we distribute. And so any of your quadratic strategies are fair game here. So I'm going to set this equal to 0. X squared minus 7x minus 8. That does end up being factorable, x minus 8, x plus 1. So x is equal to 8 and negative 1. But we can't just assume that those are going to work. We have to check. So if we check with 8, log base 2 of 8, that's fine. In here, it would be log base 2 of 8 minus 1, which is 1, also fine. Now, if we do this again and check with negative 1, if I plug into the first one, right away I get log base 2 of negative 1. That is not allowed. We cannot take the log of a negative. So that means that even though we got 2 solutions, there's only one viable solution in our solution set. Okay? Go ahead and pause the video and try number 15 on your own to see if you understand this process. I'll be back in 3. All right. I ended up getting 2 solutions from my algebra, 5 and -2. But when we plug back into the original, -2 does not work in the domains of those logarithms. So 5 is the only solution that we can work with. Now remember, it's not always going to be addition. If I had log of x minus log of x minus 3, then that would be the log of x over x minus 3, and then you're working with rational equations, which we also know how to do, but just remember you're going to have to be able to go with either of those cases. Now, there's also a one-to-one property of logarithms that is very similar to what we did with exponential equations. Here we're going to see some rational equations if you need a little refresher on that. So just like with exponents, we said, if you have seen this video already, that if b to the m is equal to b to the n, then that means that m has to be equal to n. Well, the same is true for logs. If I know that log base b of m is equal to log base b of n, it must be true that m is equal to n. Again, the logs don't cancel. This is just an if-then property. If I know this, then I also know this, okay? So in order for this to work, we have to get both sides of the equation to be a single logarithm. And so that's what we're going to do here on 16 and 17. So on the left-hand side of this equation, on number 16, I have 2 logs. That's a problem. So we need to condense them together, and since it's subtraction, this will become the natural log of x plus 2 over 4x plus 3, and that is equal to the natural log of 1 over x. Now, if I know that these natural logs are equal to each other, then I know that what's inside them must be equal to each other. And so we write a new relationship. X plus 2 over 4x plus 3 is equal to 1 over x. Now, because this is just 2 fractions, I would treat this like a proportion and cross multiply. So we get x times x plus 2 equals 1 times 4x plus 3. Now we're ready to solve. X squared plus 2x equals 4x plus 3. We have a quadratic again, so let's get that equal to 0. X squared minus 2x minus 3 is equal to 0. That one works out to be factorable as well. X minus 3, x plus 1 equals 0. So the algebra tells us that 3 and -1 are our candidates. Now, let's check up here. If I plug in 3, I get a positive. 3, I get a positive. 3, I get a positive. Is that true if I plug in -1? Well, if I plug in -1 to the first one, I do get a positive. -1 plus 2 is positive, so that's fine. If I plug into the second one, -4 plus 3, I get a negative, so that is bad. So -1 has to be thrown out, and 3 is our only solution, okay? One last time, please pause the video, try number 17 to see if you understand, and I'll be back with the answer in 3 seconds. All right. Notice that when you cross multiply, you do end up having to do some foiling here, and we get it equal to 0. And this time, both of our solutions end up satisfying the domain of all 3 of the logs. So we do have 2 different solutions for this one, okay? Now, we're not going to do these last couple of examples. These are just kind of application problems. These would use either your log equations or your exponential equations, but definitely take a peek at these so you can see some of the applications that you would use this for. You would solve these equations exactly the same way that you solved the ones above. You just have to plug the right numbers in and solve the equation. So these are posted in the PDF document online. But definitely take a peek at those, but the process is exactly the same, so I don't think we need to take time on this video to do that now. So that is what we need to know about log equations, and that is all for today.